Now let's dig in a little bit more on the experimental and correlational design. Let me reiterate that these short videos are not supposed to replace you reading up on some of these concepts that we're discussing. It's just to provide a quick introduction for you so that you have a basic understanding of some of these, so that you can move on from these to develop in-depth learning, in-depth understanding about these concepts. So reading materials will also be added to these on the platform that we're using. So let's go more into details about experimental and correlational design. The true experimental design is interested in proving or disproving a hypothesis mathematically using statistics. So it's not about just looking at things with just logic. You want to use statistics to prove that what you have observed is not due to chance, it's due to real differences that are observable in nature or within the condition which you have carried out the experiment. So for an experiment to be true experimental design, the sample group must be assigned randomly. So it's not that you select these people to be a specific type of people to be in the control group and the specific set of people to be in the test group. No, it must be random. The sample group, there must be a viable control group. If you are saying you are doing true experimental design, the control group must be viable. For example, I've seen some people saying they're doing experimental design in which they are using a certain location as a control, and they are testing for water quality in the Niger Delta, whereby they are using a certain place also within the Niger Delta as a control. How viable is that the place you're selecting has also not been impacted by human activities? There is no way you can find a viable control group for this kind of experiment, because a viable control group where you are trying to look at water quality across different places means that there is a particular place where there has not been any human influence and it is similar to the place you are looking at as the test area. So those kind of work that you carry out in the field, they are not true experimental design. So people don't fall into this error on calling experiment whereby you go research whereby you go and take samples from the field and call it experimental design. They are not experimental design. For a research or a design to be true experimental design, only one variable can be manipulated and tested at a time. You control for every other thing and you modify only one variable at a time. Okay? Such experiments are easy to handle. It is also possible to control for more than one, but it becomes a little bit cumbersome because then you start having interaction. Okay, so if you know you can handle more than one variable at a time in terms of how you can explain it, it's better if you stick to one. But it is possible to do more than one at a time, but the ideal would be you test one variable at a time. You control for all the other conditions and you change only one at a time. Okay? Test subject must be randomly assigned to either control or experimental. That reiterates what we said earlier. There must be randomness in how you assign groups. So when we look at non-experimental design, and in this case now let's focus more on the correlational designs. This is the choice in social sciences because we are looking at something that is already happening in the real world. It's difficult to put the real world in the lab. Okay, so we have little control or no control at all over the study's independent and dependent variable and numerous potential confounding variables. So we find ourselves studying human interactions, studying human experiences, studying human outcomes and how they behave in the real world. So you have little or no control over that. Okay, so often we have to measure all these variables at the same time as you're measuring socioeconomic condition of the people or socioeconomic status of the people. You are measuring their perception towards sustainability, or you are measuring people's socioeconomic condition, and you are measuring their perception of household or partner violence between couples. Okay, the perception of this kind of or you are looking at how education, level of attainment in education is related, and you are measuring that, what is their highest level of educational attainment, and you're looking at what is their perception around economic independence for their wife or their partners and things like that. So there are a whole range of things like that that you have to measure the two variables at the same time. So then we usually look at whether there are correlations among variables or differences among groups. So are these two groups similar or they are different? Or are these variables, this set of variable or this particular variable related to this variable? So when we have correlational design, inherently we cannot control for the confounding variables. So it makes it very difficult for us to say this causes this. Okay, remember when we're talking about weak and strong hypothesis. Okay, strong hypothesis may be able to give you direction. Weak hypothesis will give you no direction and no causality. So remember, we can say relationship, okay, but it is difficult for us to draw causal inferences when you are looking at correlational design. But in true experiment, it is possible for us, in experimental design, it is possible for us to draw conclusion about what causes this. But when we are doing correlational design, that is much more difficult. So that is why we usually have high external validity for correlational design but low internal validity, because it is difficult for us to capture the real relationship among variables, but it is very high that we will be able to generalize the result from our particular samples, from a particular study. If the sample is representative enough, we will be able to generalize from that study for the entire population. So when we do non-experimental design, we usually rely more on correlational design. Okay, but however, the question comes to mind that if you found statistically significant correlation between two variables in a non-quasi-experimental design, does that necessarily mean that there is a causal relationship? Remember, we said no, not necessarily, because if you look at some example, if we find relationship between income and sexual violence, does that mean level of income causes certain level of sexual violence? Not necessarily. If we look at if somebody comes up with a found association between armed robberies and cold weather, are we saying cold weather causes more a certain level, or a particular temperature leads to a certain level of armed robberies? If somebody says they find relationship between longevity and pollution, are we going to say pollution causes longevity? So all these examples show us that even if we found correlation, it doesn't mean there is causal relationship. Association or correlation does not imply causality. Have this at the back of your mind. What can a significant relationship mean? A significant correlation mean? If we found a statistically significant correlation in our study, especially when we do correlational or non-experimental design, what does it mean? We will explore that in the next